Welcome to another Achieving Science video. This video is going to cover nanoparticles. Nanoscience is a new science. A science that covers and refers to structures that are very, very small. Structures that are between 1 to 100 nanometers in size, of the order of a few hundred atoms. Nanoparticles have different properties from those of the same material in bulk, because of a high surface area to volume ratio. This means that smaller quantities are needed to be effective than those of the materials with normal particle sizes. For instance, gold. The melting point and boiling point of nanoparticles of gold are much lower than those of the bulk material. If we look at some numbers, and we look at the difference between nanometer and a micrometer, you can see that the micrometer is larger. The easiest way to write these are in standard form, where a nanometer is 1 times 10 to the minus 9 meters and a micrometer is 1 times 10 to the minus 6 meters. If we look at some particles, a coarse particle is a particle with a diameter between 2,500 nanometers and 10,000 nanometers. They are referred to as dust or PM10, where PM10 stands for particulate matter up to 10 micrometers in diameter. Fine particles have a diameter between 100 nanometers and 2,500 nanometers. They are referred to as PM2.5, where PM2.5 stands for particulate matter up to 2.5 micrometers in diameter. The typical atom, it has a diameter of about 0.1 nanometers. A small molecule usually has a diameter of less than 1 nanometer. This means that nanoparticles are between 10 and 1,000 times bigger across than a single atom, and up to 100 times bigger than small molecules. In summary, this can be seen via a diagram. A nanometer being between 1 nanometer and 100 nanometers. A fine particle between 100 to 2,500 nanometers. And a coarse particle between 2,500 nanometers and 10,000 nanometers. Hopefully you can see this diagram, the differences in size. Referred to earlier in the video was surface area to volume ratio, which was a cause for the differences in properties. Nanoparticles have very high surface area to volume ratios, but what does this mean? A high surface area to volume ratio means the surface area is very large compared to its volume. Think about, if you make a fist with your hand, the surface area is quite small compared to if you open up your fist and stretch out your fingers, the surface area suddenly becomes a lot larger. The surface area to volume ratio then can be calculated via the surface area being divided by volume. We take these examples. If we have two cubes, A and B, where the height, width and depth are all identical, where A is 10 times bigger than B. If you pause the video now, try and work out the surface area, the volume, and then the surface area to volume ratio for both of these cubes. The answers then are shown on the screen. In conclusion, we can see that as the particle decreases in size, the size of the surface area increases in relation to its volume. We also see that by decreasing the size by a factor of 10, causes the surface area to volume ratio to increase by a factor of 10. Nanoparticles then have many different uses and applications. They can be used as catalysts to speed up chemical reactions without being used up. Because of their high surface area to volume ratio, it means that more atoms of each particle is at the surface and so able to interact with the reactants. This means that less is needed to work effectively as normal sized particles, which is vital, particularly if you've got a catalyst that is gold, for instance, that is very expensive. The less of it that you need, the better it is going to be for you. They're used in clothing. Silver nanoparticles have been added to socks. This stops them from absorbing the smell of sweaty feet, as the nanoparticles have antibacterial properties. In healthcare, they can be used in sunscreens. They offer protection and can be rubbed in so there is no white marks. In sports equipment, they can be added to materials to make them stronger, whilst offering being lighter, and therefore can be used in tennis rackets, golf clubs and shoes. They can also be used elsewhere, and there are advantages and disadvantages to all of their uses. We've already seen some uses in medicines. There are also uses in cosmetics, electronics, deodorants, and fuel cells.